Hi everyone, this is lesson 2 part 2. Let's continue with this topic, permutation and combination. We look at factorial notation. I kind of go a bit fast at the end to touch on the permutation, but I would like to redo that part again. Okay, so the first part of last lesson is all about this notation, new operation called factorial. It's a quick way to write numbers such as 37 times 36 times 35 all the way down to 1. So it's just a quick way to do that. And now let's focus on the second part, permutation. All right. Now in this whole unit, we will deal with two kinds of question. One is permutation, one is combination. All right. What is a permutation? The permutation is when the question involve they're all asking about like how many ways of arranging something. But then for permutation question, the order of the arrangement is important. So that makes it a permutation question. When the order of the arrangement is not important, right? When they don't count as different arrangement, we call that a combination question. The example is access code, right? You need an access code to open your iPhone. Let's say you contain a 357. So entering 357 and a 537 is a different access code. The order matters here, is important. So therefore, for this kind of question will be a permutation question. Whereas combination question that you will see 2 lessons later, that is the order doesn't matter. For example, the question is, oh, how many ways you can bring your books to school, okay? And then let's say you have science book, math book, English book, social study books, and then you can only take 2 at a time because it's too heavy. So how many different combination can you bring? So let's say you bring math and physics book. Well, by bringing math and physics, is it the same as bringing physics and math? It is the same, right? It's just like which books you can bring to school. If you can bring 2, bringing math and physics is the same as bringing physics and math. You won't count that as 2 different arrangements. So in that case, the order of the books doesn't matter. It just, right, it's only concern what are different combination you can bring. So that will be combination question. Okay, anyway, let's look at some example here. The order of element is important. What are some example for permutation question? Number 1, when you're arranging letters, all right, it's permutation. To arrange all letters of the word cat, so you have 3 letters. First, you have 3 choices. Next is 2 choices. The last one is no choices because it's that with 1 choices. It's 3 factorial. All right. And then we can also say, hey, is n factorial, like general rule. If you just want to arrange n object, right, n different object, okay, we'll make a distinction here, different objects, then the answer is n factorial. So using the factorial, we summarize it. We have seen this kind of question in previous unit in lesson 1. So this is just summarize it. So how many ways of the permutation? Well, the 6th letter here is 6 factorial. There are 7 letters here, so it's 7 factorial. Now let's be more specific. We have seen similar question in lesson 1 as well. Permutation of n different objects taken out at a time. So sometimes when you have, let's say here, 1, 2, 3, 4, 5, 6, 7, 8. You have 8 different letters, but you're not using all of them. You only need 3 of them, right? So you're putting 3 there. You only need 3 of them. You're not arranging all 8 of them. So the answer is not 8 factorial. But the answer would be 876. It still has a pattern of factorial, but it doesn't go all the way down to 1. So what do we do? Right here, they show you the math. If it's meant to be A76, I can also write it this way. A76, 5, 4, 3, 2, 1, there's 5 factorial, and then over 5 factorial. Why do I do this? Why do I introduce this part? Because they can be cancelled out, 5 factorial, 5 factorial. But by introducing that, on the top, I have 8 factorial, right? I have 8 multiplied all the way to 1. I can't do that with just A76 because where is the 5, 4, 3, 2, 1? But now by writing it this way, 5, 4, 3, 2, 1, I can write A factorial. But you just need to divide by 5 factorial at the bottom. Well, looking at the question, I only have a 3 and an 8. Where does the 5 come from? 5 comes from 8 minus 3. So therefore, this is the general form for solving this kind of question. And then since you see this all the time, we make a notation for that. We call that AP3. This is a permutation question. That's why we use the P. You have A object. You are finding the permutation for any three of them, three among eight. So NP3, that's the meaning. And R is always less than or equal to N, right? If you just have N object, you can't pick more than N, right? So R is always less than N. And then I use the word pick. Pick is like you carefully pick, you're picking. So it's very selecting. The order is very important. So the P and pick and like permutation, this is like easy way, casual way, easy way to say and pick R. All right. So we use that when you have an object and then you just need to pick R at a time. And then you have such key in your calculator. So go to math and then you move right twice, which will give you the probability menu. And then in the probability menu, I think it's number 2, you actually see NPR. So you just choose number 2, or you go down and hit enter. Then you will, given this NPR again, you can fill in the number. And you get the answer. All right. So in here, to be consistent, they need to define, right, definition of 0 factorial. If we allow n factor, like if we have the S n p n, if I have n object, I take in all n at the same time, take in all of them. This is just like the original question. We know the answer is n factorial. However, the definition of p is this way, so we end up with the 0. So in order to be the same, I need to define 0 factorial to be 1 in order to be consistent. Okay, for this to be equal to, you need to be 1. Okay, it's just explaining how come 0 factorial is 1. Let's see how do we use it. In a region, vehicle license plate consists of 2 different letters. Different. Has to be different. Followed by 4 different digits. They have to be different. If the letter I, O, Y, Z are not used, determine how many ways, how many different license plates are possible by the fundamental counting principle. We learned that. There are 2 different letters. There are 4 different digits. All right. There are total 26 letters, but I can't use this 4 because they may be confused with letter 1 and 0 and so on. So 26 minus 4, I only have 22 to choose from. The answer is 22 and 21, right? You can't be the same as that one, so that's why it's 1 less. And for digit, there are 10 digits to begin with, but then you can't different, so you can't be the same as the previous one, can't be the same as the previous 2, can't be the same as the previous 3. So that will be the answer. Now for this question, if you use, you can also use permutation. You don't have to, but you could, right? Because do you see this pattern? When you see this pattern, a number multiplying with other number in descending order, you know this is a pattern for permutation. So you can use permutation. But as I say, you don't need to. The problem with permutation and combination with student is they are doing fine in lesson 1, but once they learn lesson 2, 3, 4, and 5, when they introduce a concept of permutation and combination, they thought it is like they thought they have to use permutation and combination to solve all the problem, or they thought it is better to use combination and permutation, or it is smarter to use them. No, all right? You only use them when you need to. If you don't need it, you don't need to bother. If you can do it without the permutation, you don't need to. And some questions are not meant for permutation question, then you don't use it. All right. So fundamental counting principle is something you learn in lesson 1. You can look at that as a separate topic. Some question need to solve by fundamental counting principle. Some question can only be solved by fundamental counting principle. They're not meant to solve by permutation and combination. But some question could be solved by both methods. Then you can either use it or not, right? Some questions have to solve by permutation. Some questions have to solve by combination. All right, permutation, how do you solve it? Basically, you have 22 letters to choose from. You're only picking 2 of them. And then the order is important. And then you have 10 digits to choose from. You're picking 4 of them to form your vehicle license plate. And since your license plate is formed by two letters, do I say two letters or four letters, four digits, or do I say two letters and four digits? Well, you would say the license plate is formed by two letters and four digits. When we say and, do we multiply or plus? When we say and, we multiply. So you multiply this. So these two will give you the same answer. Basically, these two things are the same. All right. So look at the notes. In many cases involving simple permutation, the fundamental counting principle can be used in place of the permutation formula. This is very important. Again, after people learn permutation, they thought everything have to be put in the permutation form. No, it doesn't have to. It's just a tools. It's just to help you. If you know you can do lesson one, and when you see a question that you can just solve it with the method in lesson one, you don't need to bother with the permutation question, the notation. You don't have to. All right. All right. So having said that, you can try the homework. All right. Well, since this is lesson two, I think most of the question will be done by permutation. But don't forget what you learned in lesson one. All right. You have good foundation in lesson one. You can solve many of the question without permutation. You just write how many choices are there. You just multiply them using fundamental counting principle. Just keep that. And now just adding. For some question, you may use permutation. All right. You can try your homework now. Bye bye.